Making your way in the world today takes everything you've got. Taking a break from all your worries sure would help a lot. Wouldn't you like to get away? Sometimes you wanna go where everybody knows your name, and they're always glad you came. You wanna be where you can see.
In this video, I am going to talk about the disk method, how to find the volume of a solid generated by rotating it around the x-axis. So this is my equation which will help me to figure out the volume of the solid. This is my volume notation, this is the integral notation. So this is my lower limit, this is my upper limit, the pi as a constant, r square the radius. So the pi we will pull out as a constant. So yeah, so x square is our equation, which is looks like a parabola here. So but we need only from 0 to 2, so we just use this part over here. So this is my graph here, this is my radius. Actually it will the half shape by rotating the around the x-axis. This is only the half one, like that. So this is the x square part. So here we can put, in place of r square we can put x square. So this is the x raised power 4, pi in front, and we can use our calculator to figure out the answer.
Alright, so here's the washer method, and the equation for the washer method is volume equals pi times the integral r squared, big R squared minus little r squared dx. And in this equation, to find your limits in the integral, you're going to set the equations to each other and you get x equals 3. And when you plug everything in, you pi times the integral of 0 to 3 times 2 squared minus 2x over 3 squared. And this is it simplified. And when you plug that all into your calculator, you get 8 pi. And this is the graph of that. And your big R is the highest equation, and your little r is the smallest equation. And then in the equation, you subtract the two. And that is how the washer method works.
This is the shell method. As you can see, to find the volume of an object rotating around a line of axis, by using the shell method, you use v equals 2 pi times the integral of the radius times the height dx. This is basically just finding using the circumference of the object itself and basically unfolding it into a rectangle to find the area. So as you can see, for this problem, we are integrating from 0 to 1, and we are rotating around the line x equals 1, and our equation here is x squared plus 1, so we're taking 2 pi times the integral from 0 to 1 of x, which is the radius, times the height, which would be your equation, x squared plus 1 dx, and that equals 3 pi over 2.
And now we're going to talk about the square cross sections. And basically, I'm just going to remind you guys that to find the volume of something, it's just the integral of the area with an upper and lower limit. So here we just have a graph from 0 to 3, and we're going to take the volume by taking the cross sections of squares perpendicular to the x-axis. So basically, it's like this. Like right here, you have a whole bunch of little squares, and as you get like over here, you have higher squares, and the squares get a little bit taller and whatnot. So basically, here's just a little diagram of how they get bigger as the curve goes up. And basically, we all know that a square has equal length sides. So the squares will just be 3 and 3, and you can simplify that by going x squared, because this time this will just be x times x, which is x squared. So it's pretty much simple from here. All we have to do is plug in x squared for our area, which we had above here. So it says the volume from 0 to 3 of the area, which we now know is x squared. We just plug that in and we find the integral, which is just 1/3 x cubed. And then we have to plug in 3 for x, and then minus it by this with 0 in it, and then we get our answer, which is 9. So that's it.